Good afternoon, and welcome to today's Museum of Science Live program. Today, we're talking to three museum educators about climate change, how our planet's atmosphere has been altered in the recent past, what the causes are, and hopefully, what are some of the solutions we've come up with. My name is Eric, my pronouns are he, him, and I'll be your moderator during today's program, which means I'll be fielding all of the questions that you ask our panelists. If you're joining us on Zoom, to ask a question, just press the Q&A button at the bottom of your screen, include your name and age if you'd like, and go ahead and type in those questions anytime. If you'd like to see captions, you can click on the closed caption button at the bottom of your screen and select show captions if you're joining us on Zoom. And if you're joining us on Facebook or YouTube, we won't be able to take your questions, but we're happy you're tuning in. So at this point, I'll ask my panelists to turn on their cameras, say hi, and we'll be ready to get started.
Hi, everyone. My name is Becca. My pronouns are she and her. And the thing that's most interesting to me about climate change is really everything to do with the Earth, specifically because I am a geologist. So I like kind of knowing what the Earth has done in the past and what it's doing now. So everything that's kind of related to what it's currently doing and how that's different from the past is the most interesting to me.
All right. Hello, everyone. My name is Jonathan. I use he, him pronouns. And I am an anthropologist by training, so I am most interested in how climate change impacts us as individuals and as societies.
Hi everyone, my name is Sarah. My pronouns are she and her, and I am a marine biologist by training. So I am really excited to talk about how climate is affecting our oceans.
Well, thank you all so much for joining us. Again, if you've got questions for our panelists, go ahead and type them in on Zoom using that Q&A function. And why don't we start out by talking in some general terms and the difference between climate and weather. Can you tell us what that is?
Yeah, I can start with that one. So these two terms are often interchanged, but they are a little bit different. So weather is thinking about now. What is the weather outside? Right now, I can say that it is very sunny here, it's blue skies, and it's actually kind of cool where I am. I mean, it's still 70 degrees, but it feels cool after the summer. That's me describing the weather. When we're describing climate, we're usually talking about a long period of time, usually over 30 years of time or more. So we're talking about the general area that you live in. What is the climate? I live in New England, so I experience all 4 seasons. It's going to be talking about what we are expected to experience. A good analogy I like to use is that weather is whatever we're wearing that day, what we put on. If it's raining, we might put a rain jacket on. Right now I have short sleeves on, but climate is what you see in your entire closet. What is your entire wardrobe for what you would wear for that entire year?
And so we're talking about climate change today. So can you tell us what is changing about the climate and what's causing that?
Sure. So there's sort of a few things that are changing, but when we think about climate change, we often equate that with rising temperatures. And because generally what's happening over climate kind of everywhere is that that is true. In fact, global average temperatures are rising, but it doesn't necessarily just mean climate change in temperature rise. There's a lot of other parts of the climate that are changing. We'll see different weather patterns, as we were just saying, that they're different but sort of related. And so there's the idea that it's changing because of something warming it up. And that something is greenhouse gas emissions that are sort of almost like a blanket kind of covering the earth, trapping heat inside. So when the sun reflects off of the earth, it just gets trapped and sort of warms it up overall. So that's sort of what's changing overall, but there's a lot of different variables inside of it. And I'm sure both of you could even add to that definition.
Yeah, I'll add something quick. It's basically what you said, but we also use the word global warming and climate change kind of interchangeably. And we are experiencing global warming. As Becca said, we're getting a lot warmer, but climate change is talking about all of the effects of the warming. So although we're getting warming, we're not only seeing higher temperatures, we're seeing sea level rise, we're seeing more rain, more hurricanes, more drought. Our sea ice is starting to melt. So although it is global warming, we usually use that term climate change because it's talking about the entire world and everything that's happening because of global warming.
So we're getting some questions coming in about hurricanes, storms, things like that. So before we get to them, can you just talk about the relationship between climate change and things like severe weather?
Sure, definitely. And kind of a little bit of what Sarah was just mentioning, that there are things that are changing. So when it comes to storms and hurricanes, we've noticed that the past few hurricane seasons in the past several years have gotten worse. And that doesn't necessarily mean that there are more storms per season. I mean, there's always been storms in every hurricane season as far back as we can go, but it just means that they're getting a little bit worse. That's mainly because the ocean temperatures are rising, and that warm water is what feeds a hurricane. You have to have warm water, you have to have hot, humid air. And that's why they often happen kind of along the equator, where that is there's a lot of it. There's a lot of warm water and hot, humid air. And so as soon as that starts to happen, you get more and more of them, and they just keep feeding this system of swirling air that is hot, and it's carrying all of this moisture as it moves along with the the equator streams and the Gulf Stream up there, as it heads most of the time towards Florida or somewhere on the southern part of the United States. And so yes, there are definitely some more extreme ones, and that's one of those things that we've noticed happening, but it's not necessarily the only thing happening, and it's not necessarily that there are more hurricanes. It's just that they're getting a little bit more extreme.
Yeah, I think another way we like to say it is that it's sort of increasing the frequency and severity of major weather events. So again, and sort of as both Becca and Sarah have been hinting at, that can be very different depending on where you are on the Earth and at what time, because the climate system is incredibly complex. So for some areas that will mean increases in rainfall and increases in flooding. For other areas that means a lot less rainfall and a lot more extreme droughts. It can mean, increases in the temperature that creates tornadoes or hurricanes, or all sorts of things that are impacted within the weather system because of that shifting climate over time.
So following up on that, Nico had a couple questions about these storms. Are hurricanes made out of water? And what's the fastest speed for a storm on the Earth?
Definitely looked this up before the weather panel we had like a couple months ago, but I don't remember the fastest speed right at this moment. I know it was a hurricane, I believe in the 90s, that went towards Texas, I think, but I can't remember exactly how fast it was. But when it comes to, are they made of water? Technically, yes, they're made of water vapor and they're made of water droplets. You have to have warm water in order to start feeding that system of the swirling air, and it continues to feed on that warm water. And once you hit land, it tends to stop moving as much because there's nothing really feeding the system. So it is technically made out of water and water vapor. That's really what you need in order to have a hurricane. But the fastest speed escapes me. I'm sorry.
So we have a question from Leo asking about our models that are predicting this climate change. How do we know they're accurate and we're not missing some things that would show it's actually a natural event? We haven't been able to explain why everything in our past happened. So what's different about this? How do we know that it's real?
Yeah, that's a great question. And it basically just comes down to considering as many variables as possible. We've mentioned again and again that climate is incredibly complex. It has a number of different variables. And it's also really important to note that we as individuals, or no individual organism or species, experiences climate. We experience weather. Climate occurs on such large timescales that we don't actually process it cognitively. And so our only experience of climate is largely through computer modeling. And so over time, what scientists have been and researchers have been able to do is to add more and more models. As our computer modeling has improved, as our computer accuracy and just data processing in general has improved, we've been able to refine those models over time. And we're not guessing 100% what's going to happen. We're not sure when any any particular storm is going to hit or how severe that particular storm is going to get. Those are still well beyond our computing powers, but we can make relatively well-informed decisions about what sort of future events are going to hold. And we know that those are going to be relatively well-informed and accurate because we can compare them to past data. So we make predictions, we see what the actual trends then are, and we adjust our models, and we're continuously adjusting our models. So in fact, there's some really exciting research going on right now about machine learning and artificial intelligence, which researchers are now using to sort of rewrite our predictive algorithms so that we can create even more accurate models. But that's why when we talk about climate, we can't necessarily refer to, oh, such and such a hurricane was caused by climate change, right? Because we can't link those two things. We don't know all the variables that were involved, and that's still beyond sort of our processing power.
And it is also interesting to note, in addition to everything Jonathan just said, that the Earth has gone through periods of warming and cooling in the past. However, it's done so on a much longer geological timescale than what we're currently experiencing. We're currently experiencing something that over, Jonathan was saying, about 30 years, like we really have noticed changes. Whereas in the past, it would have been a little bit even longer of a timescale for these changes to have happened based on our computer modeling and based on our evidence in rocks and in other things that we have on the planet. So it's interesting to note that, yes, there have been periods of changing before, but what's happening now is just a much different speed that it's happening to.
So we got another question from Nico asking more about what you mentioned, I believe Becca did with the greenhouse gases. Why is it that carbon dioxide and greenhouse gases make the Earth warmer? How does that work?
Yeah, I can answer that one. So we like to sometimes compare it to a blanket. Earth has an atmosphere that creates this nice little blanket around us, and we really want that blanket. We need that blanket to survive. That's what makes Earth have life on it, because we are trapping a certain amount, a good amount of heat into our Earth that allows us to have a climate that we can live in and we can survive in. If we didn't have those greenhouse gases or that blanket that surrounds the Earth, we probably wouldn't have been able to live here. So they are good to a point. But what we have been seeing is we've been adding a lot of carbon dioxide into our atmosphere, much more than we have ever added before. And we've been adding it since at least 100 years. So we've been adding so much carbon dioxide into our atmosphere that it's too much for our natural systems to adjust to figure it out. So carbon, you can think about the carbon cycle. I won't go through all of it, but it comes out of the ground into the air, into our trees, and it keeps that cycle going. What we're doing is we're pulling too much out of the ground and burning it up into our atmosphere. So with more carbon into our atmosphere, that means that we have that thicker greenhouse gases or that thicker blanket, and we're trapping more and more of that solar radiation into our Earth, which is making us a lot hotter. So yeah, that's why carbon dioxide. And there's other greenhouse gases as well, but we usually just, for simplicity, usually talk about carbon dioxide.
Yeah. I think I would just add on to that answer because I like the sort of molecular component of it. I'm a bit of a nerd there, that it has to do with the shape of a carbon dioxide molecule. So if you think about it, CO2, you've got a carbon in the middle, two oxygens on the side, and they're bonded together. And those bonds can absorb energy, which is essentially the movement, the vibrations that those molecules are going through. So carbon dioxide absorbs a particular energy that would otherwise be re-emitted back out into the space. And we need a little bit of it because we want that energy to keep the planet warm, as Sarah was mentioning, but too much carbon dioxide, we are absorbing too much of that. And there are other greenhouse gases, nitrous oxide, carbon monoxide, all sorts of those. The reason why we often talk about carbon dioxide is because that molecule is so stable that it persists for a really, really long time. So if we were talking about, say, nitrous oxide, another greenhouse gas, we only have to worry about that for 30 years because those molecules vibrate vibrating it like that, they'll break apart and they'll release that energy. But carbon dioxide can store that energy for 100 years or more, long-term consequences as a result of just sort of the makeup of those individual molecules.
So we've got a couple more questions about storms. With Dennison asking what was the most dangerous hurricane. Nico wants to know what the largest storm on Earth was. If you don't have those off the top of your head, maybe just talking about how what the dangers of those storms are, or a particular one even recently that's made headlines, and some of the dangers that came with it.
Sure. Once again, I did have these all in mind with the weather panel, but I did not relook at them, so I don't remember exactly which one was the largest. I know that Hurricane Andrew was really large in Florida a very long time ago. That's one of the largest, not a very long time ago, but it was a good amount of time ago, and it was one of the largest ones. But there are a lot of dangers when it comes to storms. Especially when it comes to the winds. The winds can damage a lot of trees, can cause power outages. Also the rain, it can definitely cause for some flooding. But there's also there's so much power in those storms that when they do hit certain places, like perhaps a dam or somewhere that is containing a lot of water, or somewhere that is a power source, it can do a lot more damage when they hit somewhere like that. So storms are really serious, and as they get a little bit more intense, they definitely get a little bit more dangerous for the people around them. I mean, think about Hurricane Harvey, which happened just in 2017 and was actually one of the images on our title slide there. 2017, there was Harvey and Irene and Maria, I think, were the three big ones that happened in a 2-week time span. And so they were all pretty devastating depending on how quickly they moved. Harvey was very slow, and so it sat over the same area for a long time, having a lot of devastating rainfall, causing a lot of flooding. So there's definitely a lot of damages with them, and they can be incredibly powerful. But the largest one, I just can't think of at the moment. I don't know if either of you remember the largest. It might be Andrew. I could be making that up.
I don't remember for sure. I do know that there's different ways of categorizing what makes a hurricane dangerous. So either you can do it by how deadly it was, how catastrophic it was to the area, like how much it costs to rebuild, and then how big it was. I do know that one of the highest costing hurricanes economically, I think, was Hurricane Katrina. And that was because of the levees, as Becca was talking about, other factors that caused it to happen. I want to say one of the biggest, I have like Texas in my mind for some reason as one of the biggest hurricanes. I don't know for sure. I'd have to look it up. But I think Becca was making like good points that hurricanes, it depends on a lot of factors on how dangerous that they can be. So we have our wind speed and how big they are, but there's other things on top of that that causes hurricanes to be worse. And one of those things would be if the hurricane came in at high tide, if we had a really big storm surge that day. So that is an example of that was Hurricane Sandy that hit the Northeast US. Although it wasn't a very large category hurricane, it caused so much flooding in New York City because it came when they were at really high tide. So all of that water got pushed into New York City. So there's a lot of other things that causes hurricanes to have more flooding or more damage. But yeah, I don't know the actual biggest hurricane.
I knew it at one point.
So we got a question about credibility, and with the pandemic ongoing, it's been really tough to know with conflicting sources of information. So similarly for climate change, who do we trust when it comes to predictions and the best information about climate change?
That's another great question, and one that certainly deserves a serious response in terms of, yeah, there's absolutely a lot of misinformation out there about climate change and about its connections to weather and things of that nature. I think what's important to note is that, as I mentioned earlier, you know, we're creating predictive models. Researchers are creating predictive models. So we're not coming up with hard and fast, this is what's going to happen. We're making a prediction, and then then observing the results, right? So those predictions are not necessarily wrong in the sense that we were saying something was going to happen and it didn't happen. They may have been inaccurate. So we learn from it, we acquire more data, and we make more accurate predictions moving forward. What we're seeing as we increase our computing power and things of that nature is that those models have become closer and closer to our observed realities. And so researchers in general involved in climate science are getting much better at predictions, but we can even observe it in our own lives, right? Over the course of the past few summers here in Boston, we have had an increasing number of extraordinarily hot days and have had to begun to pay attention to things like the urban heat island effect, because apartments can become overwhelmingly hot. That's happening in a lot of different areas where you're having people suffering from heat stroke and things of that nature. Wildfires that are breaking out because of dry conditions. So there are things like air pollution that result because of particulate matter in the air from fires, things of that nature. Those are all sort of observations we can make of a changing climate and the results of a changing climate, increasing severity of storms over time, like hurricanes. And so as we're sort of accumulating that evidence as individuals, we can all come to the conclusion that this is a very serious problem that needs to be addressed.
Yeah, and I think a way to, I mean, there's a lot of sources that you can look at, but when you are, an easier way, I guess, to get information is I get the NOAA Climate Program Office newsletter to my email. And so that tells me the state of the climate happening this week. So those are just really easy bits of information to learn about and read about, and then you can read more about it later. And then for kids, there is a website that NASA created, so NASA Climate Kids. I think that's a really great resource to just go to learn about the basics of climate change, and then start, like Jonathan said, start looking at those things in your everyday life and looking out your window and even seeing the different changes you're noticing over the years. That is a really, your own observations are just as useful. Of course, you won't be alive for the entire time of a climate, but you're alive long enough to notice changes in your own neighborhood, in your environments, and the place that you live all around you.
So I'd like to take our last couple of minutes and kind of focus on what we can do moving forward. And Nico had a question about radars measuring climate change. So more broadly, how do we go out and measure and verify our predictions and see what we need to change? How can we measure our climate with technology?
I guess I'll start in on that. There's a lot of different ways that we can measure some of the things that are changing. First of all, there's temperature readings that can be taken from all over the world, and they will register temperatures all the time. And so that's how we know what exactly is happening if we take regular temperatures pretty much everywhere. But there's also satellite imagery, which can take some really good imagery and also data of storms and other areas that might be considered problems. We're able to then look at glaciers retreating or ice melting in the ice caps based on a lot of this radar imaging, because it's not really that accessible to go climb a glacier and measure how much it's retreated in the past several decades. But it is a lot easier to do that when you're mapping it from space or even from the air above it. And so there's a lot of new technology. As Jonathan was saying, not only are our computer models getting better, we're having a lot more technology that we're able to measure and collect data and then synthesize the data and put it into these models. So there's constantly a lot of innovation around what can be done to look at it and what can be done to maybe prevent anything else from continuing on this way and maybe hopefully mitigate some of these problems a little bit.
Yeah, and sort of continuing along that solution line, Becca mentioned mitigation, and that is sort of one of the three pots that scientists like to stick our different solutions into. Mitigation being we're going to reduce the severity of expected climate changes moving forward. There's also adaptation, so that would be something like building greenways or seawalls because and adapt to the changes that we anticipate coming And then there's also climate resiliency, where we would interfere with climate systems to try and actually change them in some beneficial way. But then there are also everyday things that we as individuals can do to help solve the changing climate. And one of the best parts about climate change is that it is absolutely a solvable problem. We understand the causes of it. We've understood it for a while, and the technology necessary to solve it already exists, right? It is abundant, affordable, clean energy. It's solar panels and wind turbines and nuclear power and things of that nature. And really the challenge is just making those cost effective enough and efficient enough that we're able to spread and store energy in a way that is accessible to everyone. But then even you as an individual can have massive impact. The most significant voice in climate change right now in the entire world is Greta Thunberg, who is a 17-year-old, right? And it's not because she is the world expert in climate change. It's not because she has a ton of degrees. It's because she speaks very passionately and works very hard at articulating what is important about a changing climate and how it's going to impact us. And particularly because she is young, we cynical adults draw from the energy that young people bring to the table and the worlds that you can reimagine and help us to understand by talking to us. So just talking to friends and family about climate change, how it's impacting others, how it's impacting you, and how we can potentially solve it can have a tremendous positive impact and go a long way to help solving this problem.
All right, and to wrap up, finally, Leo would like to know if you can recommend anything like books, articles that can help understand climate change, keep up to date on it, and what, touch on what we can do moving forward.
Sure. Well, I would quickly say my favorite website, and part of the reason why it's my favorite is because it will point you to a ton of other resources, is simpleserioussolvable.org. Simple, serious, solvable, all one word.org. And it's from an atmospheric scientist at Colorado State University. He does a great job of outlining the problem, how we can solve it, and he also points you to a ton of other resources that you can access to learn about different aspects of the climate.
All right, friends. Well, I'm so sorry that we still have some unanswered questions, but we are all out of time for today's program. So I'd like to ask my panelists to say goodbye.
Bye, thank you.
Thank you.
Thank you all for your fantastic questions. And thank you to our audience for asking those questions. Again, sorry we didn't get to every single one of them, but we're out of time for today. We'll be doing lots more of these Ask a Scientist programs, and we also have tons of other offerings on MOS at Home, such as activities and podcasts. So follow us on social media or check out our website, mos.org/MOS at Home, to see what else we're up to. Thanks, everyone. Enjoy the rest of your day, and we'll see you next time.